Welcome, my dear friends, to your channel Game Learn English. In this podcast, we are going to explore the vastness of space, the mysteries of the cosmos, and one of the fundamental questions that challenge our understanding of reality. I'm your host, Dev, and today we're diving into one of the most profound questions in all of science and philosophy. Is the universe infinite, or is it finite? This question isn't just about the size or shape of the universe. It's about the very fabric of existence, the limits of human understanding, and the future of all things. As we journey through this topic, we'll explore the concept of infinity, the evidence for and against a finite universe, the shape of the cosmos, multiverse theories, and the philosophical and existential implications of each possibility. So, whether you're a seasoned astrophysicist, a curious philosopher, or just someone who loves gazing up at the night sky, I invite you to sit back, relax, and join me as we venture beyond the horizon. Understanding the concept of infinity. To truly grasp the question of whether the universe is infinite or finite, we must first understand what we mean by infinity. Infinity is a concept that stretches our imagination to its limits. It's not just a big number. In fact, it's not a number at all. Infinity represents something without any bounds, something that goes on forever. But here's the kicker: infinity can be incredibly tricky. In mathematics, infinity comes in different forms. For instance, there's the idea of a countable infinity, like the set of all whole numbers which never ends. But there's also uncountable infinity, like the number of points on a line segment, which is a different kind of infinity altogether. When we talk about the universe, though, we're dealing with physical infinity, a space that, if infinite, has no boundaries, no edges, no limits. But can something physical, like the universe, actually be infinite? Or is the idea of an infinite universe just a theoretical construct, a mathematical convenience? Infinity, as a concept, challenges our very understanding of reality. How can something truly be endless? Does infinity exist in the physical world, or is it just a figment of our mathematical imagination? These are the kinds of questions that lie at the heart of our exploration today. The observable universe versus the entire universe. Before we delve into whether the universe is infinite or finite, it's crucial to distinguish between the observable universe and the entire universe. These two terms often get mixed up, but they refer to very different things. The observable universe is, as the name suggests, the portion of the universe that we can observe. It's defined by the distance that light has traveled since the Big Bang, which occurred about 13.8 billion years ago. Given the finite speed of light, this means we can observe objects up to about 46.5 billion light-years away when we account for the expansion of the universe. Beyond this horizon, light from more distant objects simply hasn't had enough time to reach us yet. But what lies beyond the observable universe? Is there more out there, or does the universe end at the limits of our vision? The entire universe encompasses everything that exists, even beyond what we can observe. This could include regions of space that are so far away that their light will never reach us, as well as any possible dimensions or realms that we cannot detect with our current technology. The observable universe gives us a snapshot, a tiny piece of a much larger puzzle. But to understand whether the entire universe is infinite or finite, we need to look beyond what we can see and consider the underlying structure and nature of space itself. Evidence for a finite universe. Now, let's explore the case for a finite universe. Scientists have gathered a substantial body of evidence that suggests the universe may indeed be finite in size. But what does this evidence look like, and how strong is it? One of the key pieces of evidence comes from the cosmic microwave background, CMB, radiation. This is the afterglow of the Big Bang, a faint radiation that permeates the entire universe. By studying the CMB, scientists can learn about the shape and size of the universe. The patterns we observe in the CMB suggest that the universe is flat on large scales. But here's the catch. A flat universe doesn't necessarily mean an infinite one. It could be finite but unbounded, like the surface of a sphere. Imagine an ant walking on the surface of a balloon. It can walk forever without ever encountering an edge, even though the balloon is finite in size. Another argument for a finite universe comes from the idea of cosmic topology. This concept explores the global shape of the universe. Some models suggest that the universe could have a specific topology, such as a torus or a three-dimensional sphere, which would imply that it's finite but wraps around on itself. But perhaps the most compelling argument for a finite universe is entropy, the second law of thermodynamics. This law states that in a closed system, entropy or disorder always increases. If the universe were infinite, the process of entropy could never be completed, leading to a paradox. But in a finite universe, entropy could reach a maximum state, leading to a so-called heat death, where all energy is evenly distributed and no work can be done. These pieces of evidence build a strong case for a finite universe, but they're not without their challenges. The concept of a finite but unbounded universe, where space curves back on itself, is difficult to visualize and even harder to prove. And while entropy suggests a finite universe, it doesn't necessarily prove it. So, while the evidence is compelling, it's not conclusive. Arguments for an infinite universe. On the flip side, there's also significant support for the idea that the universe might be infinite. An infinite universe is one that stretches on forever in all directions, without end. But how could something physical like the universe be truly infinite? One argument for an infinite universe comes from the observation of the universe's expansion. According to the Big Bang theory, the universe has been expanding since its inception. If this expansion continues indefinitely, it suggests that the universe itself might be boundless, expanding forever without ever reaching a limit. Moreover, the concept of cosmic inflation adds to the argument for an infinite universe. Cosmic inflation is the theory that the universe underwent a rapid expansion shortly after the Big Bang, growing exponentially in a fraction of a second. This expansion was so vast and rapid that it could have stretched the universe to an infinite extent. Another argument comes from the distribution of galaxies. If the universe were finite, we might expect to see some patterns or boundaries in the distribution of galaxies. However, as we look deeper into space, we see that galaxies are evenly distributed in all directions, with no apparent edge or boundary. This isotropy suggests that the universe could be infinite. Finally, quantum mechanics and the idea of eternal inflation also support the possibility of an infinite universe. In this theory, different regions of space could be undergoing inflation at different rates, leading to the creation of an infinite number of pocket universes, each with its own laws of physics. These arguments paint a picture of a universe that might be infinite, expanding without end. But just like the case for a finite universe, these ideas are theoretical, based on our current understanding of physics. And as we know, the universe has a way of surprising us. The shape of the universe. Whether the universe is finite or infinite, one of the key factors that determine this is its shape. But how do you even begin to describe the shape of something as vast as the universe? There are three main possibilities for the shape of the universe, each with its own implications for whether the universe is infinite or finite. These shapes are based on the curvature of space. 1. Flat universe. In a flat universe, space is not curved, and the geometry we're familiar with, Euclidean geometry, applies. This means that parallel lines never meet, and the angles of a triangle always add up to 180 degrees. A flat universe could be infinite, but it could also be finite if it's shaped like a torus, where space wraps around on itself. 2. Closed universe. In a closed universe, space is curved inward, like the surface of a sphere. In this type of universe, if you travel far enough in one direction, you'll eventually end up back where you started, just like an ant walking around a balloon. A closed universe is finite but has no boundaries, meaning you can never reach an edge. 3. Open universe. In an open universe, space is curved outward, like a saddle. This means that parallel lines eventually diverge, and the angles of a triangle add up to less than 180 degrees. An open universe is typically associated with an infinite extent. Current observations, particularly from the cosmic microwave background and galaxy surveys, suggest that the universe is flat with a very low margin of error. But this doesn't settle the question of whether the universe is infinite or finite. A flat universe could still be finite if it has a specific topology, like a torus, where space wraps around itself. But if the universe is truly flat and infinite, then it would extend forever without boundaries. The shape of the universe is one of the most crucial factors in determining its overall structure and whether it is finite or infinite. However, the true shape of the universe is still one of the great unanswered questions in cosmology, and future observations and theories may yet surprise us. Multiverse theories. Now, let's step even further into the unknown. What if our universe is just one of many? The idea of a multiverse, a collection of multiple, perhaps infinite universes, has captured the imagination of scientists and science fiction fans alike. There are several multiverse theories, each with its own implications for the nature of our universe. One of the most popular is the concept of eternal inflation, which suggests that during the inflationary period shortly after the Big Bang, different regions of space expanded at different rates. This could have created bubble universes, each with its own laws of physics and constants. Our universe would be just one bubble in an endless cosmic sea. Another multiverse theory arises from quantum mechanics. According to the many worlds interpretation, every quantum event leads to a branching of the universe into different outcomes. This means that there could be an infinite number of parallel universes, each representing a different possible outcome of every event. If the multiverse exists, it could mean that our universe is just one small part of an infinite or finite collection of universes. This would have profound implications for our understanding of reality, raising questions about the nature of existence, the possibility of other life forms, and the limits of scientific exploration. However, the multiverse remains a highly speculative concept. While it offers a fascinating perspective on the nature of the universe, we currently lack direct evidence to support it. As with many other ideas in cosmology, the multiverse challenges us to think beyond the limits of what we can observe and imagine. Philosophical and existential implications. The question of whether the universe is infinite or finite isn't just a scientific one. It's also deeply philosophical. The nature of the universe has profound implications for how we understand existence, reality, and our place in the cosmos. If the universe is infinite, it challenges our notions of time, space, and even meaning. In an infinite universe, everything that could happen might happen an infinite number of times. This raises questions about free will, destiny, and the uniqueness of our experiences. Are we just one of countless versions of ourselves, living out every possible variation of our lives across an infinite expanse of space and time? On the other hand, if the universe is finite, it suggests that there are limits to existence, boundaries beyond which nothing exists. This has its own implications, including the idea that the universe had a beginning and may have an end. A finite universe is a universe with a story, a narrative that unfolds over time and space, with a clear start and potentially a clear conclusion. Both possibilities are awe-inspiring and humbling. Whether the universe is infinite or finite, it forces us to confront the limits of human understanding and the mysteries that lie beyond our grasp. It challenges us to think about the nature of reality, the meaning of existence, and our place in the grand scheme of things. Future research and unanswered questions. As we reach the end of our journey, it's clear that the question of whether the universe is infinite or finite is far from settled. While we've made incredible strides in understanding the cosmos, there are still many unanswered questions that scientists are eager to explore. Future research will likely focus on refining our understanding of the universe's shape, topology, and expansion. New observations from advanced telescopes and experiments may provide more clues about the nature of the universe. The study of dark matter, dark energy, and quantum gravity could also shed light on whether the universe is infinite or finite. And let's not forget the role of philosophy and theoretical physics. As we push the boundaries of knowledge, we'll continue to grapple with the conceptual challenges that infinity presents. The interplay between science and philosophy will be crucial in helping us navigate these deep and complex questions. Ultimately, the question of whether the universe is infinite or finite is one of the most profound and fundamental questions we can ask. It touches on the very nature of existence and the limits of human knowledge. And while we may not have all the answers yet, the search for those answers is what drives us to explore, to question, and to imagine what lies beyond the horizon. So, is the universe infinite or finite? As we've seen today, the answer is far from clear-cut. Both possibilities present us with mind-bending challenges and profound implications. Whether the universe stretches on forever or has a finite boundary, it's a question that invites us to think deeply about the nature of reality and our place within it. As we continue to explore the cosmos, one thing is certain. The universe is vast, mysterious, and full of wonders that we have yet to discover. And as we look up at the night sky, we can take comfort in the fact that we are part of a grand and awe-inspiring universe, whether it's infinite or finite. Thank you for joining me on this journey beyond the horizon. If you enjoyed this podcast, be sure to subscribe, leave a comment, and share it with your friends. And until next time, keep exploring, keep questioning, and keep looking up. This is Game Learn English, signing off.